Hi people, this is Chaos. So in this session, we'll talk about structure of atmosphere. In the previous section, we have talked about like a composition of atmosphere, and we just started, doing this structure of atmosphere. We just got, those connections. Fine, but I hope in this section we will complete it. So structure of atmosphere. Fine. So guys, you know that what is atmosphere? Fine. So let's say this is our this is our Earth. Now the atmosphere we divide it into two layers. What are these? I'm gonna tell you. Okay. Just make it little fine. This is the first and the second. So we divide the atmosphere in two layers. This one is called as a homosphere. The inner one, and the outer one is called heterosphere. Now, what's the difference between these two? We're gonna discuss. As you might have heard about like troposphere, stratosphere, mesosphere, then we have thermosphere, then we have exosphere. Fine. So guys, here homosphere is what let's discuss here. What is this? This is homosphere, and this is let's try to differentiate between these two. So this homosphere is up to the height of 80 kilometers. Fine. It is up to the fine. It is up to the height of 80 kilometers. What about Hetrosphere? It is from 19 kilometer up to the end of the atmosphere. This is Hetrosphere. Now, in this Homosphere, the uniform mixing of air is there. Fine, a uniform mixing of all the gases. And but here in Heterosphere, you'll find that the gases are arranged in layers. We have this nitrogen layer, then we have oxygen layer, then we have this helium, then we have this hydrogen layer. Fine, and they are arranged, in the uh, they are arranged in the weightage is decreasing as we go, like nitrogen, oxygen, helium, and hydrogen. Fine, but here what we found is a uniform mixing of gases, but they are arranged in layers. So the next you can mention that they are arranged in layers. So gases are arranged in layers. Sorry, here uniform mixing, but they're layers. So gases are arranged. Oh, there is uniform mixing of gases. Here is uniform mixing of gases, but here the gases are arranged in layers. Gases are arranged in layers. This is the second thing. What about third thing I want to tell you people? Here you will find that the particles or gaseous, yeah, the gaseous the gases will be in molecule form, but here in heterosphere you'll find the gases are in atom form. So this is the next difference you can mention here. So gases will found in a molecular form, and here they are in atomic form, single atom. Fine. And the this homosphere is divided into three layers. Now, what are these three? I want to say, like we have a tropo, fine. So it is divided in troposphere, fine. Then we have stratosphere, and this is mesosphere, fine. Uh, we're gonna discuss each one of them, fine, when their term will come. But here, this heterosphere it is divided into two lists. Now, what are these two? I'm gonna write it here. The upper one is thermosphere, and the last one is exosphere. Fine. So homosphere divided into three layers: troposphere, stratosphere, mesosphere. But this heterosphere divided into three. What are these three? The thermo and exo. And you might have about like magnetosphere, and ionosphere. Now, aren't they different layers? Actually, they are not different layers. Let me tell you about it. If you talk about magnetosphere, fine. First, let's say ionosphere. Ionosphere. Now, this ionosphere is lies in between thermosphere and exosphere. Fine. So this is in between, and magnetosphere is part of exosphere. So magnetosphere lies in exosphere, and ionosphere is lies between. Uh, it is actually part of both these spheres. Fine. So you can mention these three layers here and these two here. Fine. And what's the next difference, guys? You can observe that previously we said that as we go, higher altitude, you know as the altitude increase, then what will happen? Then the water vapor dust particles decreases. So here, there will be maximum, more dust particles and water vapor as compared to this one. So we can say there is a high concentration of, here is high high concentration of uh, water vapor and dust particles, but here it is less. Fine. So there is the main difference between homosphere and heterosphere. So this is the way that we should study. So let me just give a recap that this is Earth. So it has atmosphere. So we divide this atmosphere in two layers. First we call it homosphere. Fine. Then the upper one is heterosphere. This homosphere. Now we will differentiate these two. Homosphere, here is the uniform mixing of gases, but here this is not, the gases are arranged in layers. Here the gases will found in molecular forms, but here you will find the gases are in atomic form. Another difference is that we were in three layers, and the heterosphere were into two layers. What are these two? Thermosphere and exosphere. And you may get confused about magnetosphere and ionosphere. So magnetosphere is a part of exosphere. What about ionosphere? Ionosphere is lies between thermosphere and exosphere. Fine. And what is the next difference? This is water vapor. As we go, you guys know that previously we discussed that as we go, high, uh, as the altitude increase, the water vapor and dust particles, the concentrated water vapor and dust particles decrease. So will happen here. So much in higher altitude, height increases. So here the concentration of in homosphere, the concentration of water vapor and dust particle will be high, and here it will be less. So now what we're going to do is that we're going to discuss each one of them, fine, in detail. And guys, yeah, and uh, okay, that's it. Guys, I want you to look at, there is a diagram, mentioning NCRT. I guess page number is around 73. Let me see it. We also want to draw it in our board, but it's better, if you have a look on that as well. I want to draw it on here as well, but you can see it on NCRT as well. Fine. Someone draw it. Let me show you. It's page number 73. Uh, this is, here we go. This one, the diagram that I'm talking about. Fine. So we going to draw this diagram. You can draw it with me. Fine. It'll take me some time. So what I can do is, okay, guys. Yeah, it is visible, guys. Or what I can do is, this is a rough diagram, guys. Fine. So 10, 50, 20. 20, 30, 40, 50, 60, 70, 80, 90, 100. Fine. This is, guys, altitude. Fine. So altitude increase here, and here we're gonna write temperature. So here minus 100 degrees Celsius. Then we have minus 80, minus 60, minus 40, minus 20. This is 0. This is 20, and so on. Right. So guys, look. This is we call as tropopause. This is mesopause. Then we have what else? This thermosphere. That's it. Yeah. Look. Now I want to draw the temperature with black color. Is this rough, guys? This is troposphere. And this is strato. And this mesosphere. Then we have this thermosphere. It is up to, you know, let's say 500 to 700 kilometers. Fine. Then we have exosphere. Fine. So this is troposphere. This is stratosphere. This is mesosphere, thermosphere. Then we have exosphere. Now I want to draw the temperature. 60 to 0. Low, guys. Fine. Temperature level. Fine. Yeah. This is the. Now you guys can draw this diagram with me. Let me just zoom it. Yeah. So that you can have a look. And now it is visible, guys. I hope it is visible now. Fine. I've just. I don't know whether I'm visible or not. Fine. So look, guys. Let's. This is the same diagram. I've drawn here. You can go through this one, and you can also draw this one. Fine. Both are same. Now look. When you talk about troposphere, now guys, pay attention here. If you have seen this is troposphere and this is tropopause, stratosphere, stratopause, mesosphere, mesopause, thermosphere, then we have exosphere. I'm going to discuss each one of them. Fine. So let me just, if you have noted down, let's discuss their properties. Yeah, this was the temperature. So the temperature, fine. Now look, people, if we talk about troposphere. Now troposphere, it first let's talk about temperature. In troposphere, temperature decrease as we go up, high, altitude. So temperature start to decrease. So whatever I'm writing here, you can write it in your rough. Uh, you can do some rough work. Fine. So first of all, troposphere, it is very near to the surface. Very near to surface. First thing. And here the amount of water vapor and dust particle will be high. So amount of water vapor and dust particles will be high. Fine. Because you know that as we go it start to decreasing, so this is the layer where it is having maximum uh, concentration of dust particle and water vapor. What is next? And it also undergoes a continuous friction because it is near to surface. Fine. So you know that somewhere there are hills, plateaus, mountains, valleys. So uh, when this wind flow, this air or wind flows blows, then what happens? These mountains there, it will, there will be some frictions. Fine. So friction. Now I'm gonna discuss some other points as well. Like it is zone of turbulence. This is zone of turbulence. Why there is a zone of turbulence, or we can say zone of mixing? I will discuss a concept later, that convection. So what happens? Vertical air rises here and horizontal air rises. Right. So due to this, there is a mixing. So that's why we call it turbulence. And all the weather phenomena occur in this region. This is the one of the most important. You know, all. Remember this photos. I said all. UPSC asked me give this word all. No, all the weather phenomena occur in this layer. And this is one of the one thing about this. So what is the another? There is an interesting concept like height. I'm gonna discuss that. Let me see what else is there. Strong convection. That's fine. Height. I'll discuss it later. So in this layer, guys, as we go up, so temperature decreases here. So what will happen? Temperature decrease, and it decreases at the rate of 6.5 degrees Celsius per kilometer. Every 1 kilometer, there will be decrease of temperature by 6.5 degrees Celsius. This is what we call as a normal lapse rate. Normal lapse rate. Fine. So what is normal lapse rate? As we go high, in altitude, so temperature decrease at the rate of 6.5 degrees Celsius for each and every 1 kilometer. So this is what we mean by that normal lapse rate. Fine. Actually, the temperature decreases this rate, and this is what we call as the rate at which the temperature decreases. This is called as normal lapse rate. Fine. This is the difference. Now, next we have these all the weather phenomena restricted to only this layer. We have discussed that. Then one more thing, guys. This important concept. This is important. So uh, initially First time when you read about it, you gotta confuse that. I'm gonna tell you interesting concept here. What is that? Height, guys. The height of troposphere is different at equator and poles. So why is it so? I'm gonna tell you. Let's say uh, this is Earth. Fine, fine. Here the average height is, let's say, 6 kilometer, but here is 16 kilometer. Why is it so? Can you tell me? Can anyone tell me? Think about it. So the height is not uniform. At equator, it has around 6 kilometers, but on sorry, at the poles it has around 6 kilometer, but at the equator it has 16 kilometer. Why is it so? What's the reason behind it? I'm gonna tell you concept here. Look, guys, this is equator. Fine. Equator receive vertical sun rays. Look, when there is a vertical sun rays, it will receive maximum heat. So what will happen? Due to it will absorb the heat, whatever the gases are there. So it will absorb the heat. Once it absorbs the heat, what will happen? This is the property that it once whatever the you know uh, gases or air is there, so it will get the temperature and it start try to expand. So when it tries to expand, so it will push the layer above. So due to convection, you can mention that. What is convection? Vertical movement of air. Convection is what? Uh, Vertical uh, movement of air. Fine. So due to vertical movement of air, this layer is got shifted. So at poles, what happens? The temperature is not so high. The temperature is low. Fine, and that's why the height of the troposphere is in around 16 kilometers at equator and 6 kilometers at poles. Now, guys, where will be the temperature? Less temperature. Is it equator or poles? You may think that it's poles, but actually it's equator. How I'm gonna tell you guys. When I started learning this concept, it was like I thought, then I searched, a lot of resources. Then I understood concept. What's the concept is that equator has lesser temperature as compared to poles. Why is it so? Look. Equator has a height of 16 kilometer and pole has a 6 kilometer. Fine. And let's say initially, what will be the temperature here? Here will be having the temperature, let's say 20 degree. Fine. And here, how much? Let's say 10 degree Celsius. Fine. Is it visible or not? Yeah, is it visible? So this is equator and this is pole. Here temperature 20 degree Celsius. Here is 10 degree Celsius. So I said that temperature for every 1 kilometer, the temperature decreases by 6.5 degrees Celsius. So uh, at 0 kilometer, as we go up, so how much will be the temperature decrease in temperature? So we shouldn't take that much figure because you'll have to multiply by 6 into that, so it will be negative. So let's take a rough figure. The temperature will be around let's say 2 degrees Celsius, right? And just take care of figure. It's not. It won't be 2. It will be in a negative number. Around how much? 6.5 multiply by 6. How much? 30. It will be in between minus 30 and minus 40 degrees Celsius. But let's say the temperature will be here. As we go, the temperature decreases from 10 degree to it reached 2 degrees Celsius, so temperature decreased. So here is 20 degrees Celsius, but see the height. How much is the height? So here 6 degree 6 kilometer decrease the temperature 8 degree. Yeah, from 10 to 8. Now it is 16 kilometers. Imagine how much will be there. Let's take here for 4 degrees Celsius. It is 10 degrees Celsius. And let's take 6 kilometers. 6 degree. Why? For every 1 kilometer, let's take 1 degree Celsius. Fine. For every 1 kilometer as we go up. I'm just taking example, but actual rate is this much. For just to make you understand, this is I'm taking a rough figure. For let's say 1 degree Celsius temperature will decrease for every 1 kilometer here. Fine. So the temperature initially was 10 degrees Celsius, but here, what is the height? 6 kilometers. So temperature, it will be 4, guys. It's a 6 kilometers. Fine. Anyway, but here is a 16 kilometers. So reduce the 16. How much it is? Uh, Guys, it's a 6 kilometers. 16 will be 4, guys. Fine. Let's take, something, like, okay, it's a 10 degree. Fine. So let's say the temperature will be here around 4 degrees Celsius, and here will be 2 degrees Celsius. Because when you just forget about this, we made a mistake. But if you take that one, you'll have to, reduce temperature around 18. So that, let's say if temperature is here 18 degrees Celsius, if you take that for every 1 degree Celsius is 1 kilometer. So it is 16. So that only it can come 2 degrees Celsius. This is the way. So you see that here is 2 degrees Celsius, here is 4 degrees Celsius. So temperature, where is the less temperature? Here or here. So equator will be having less temperature as compared to poles. So let me just make you one more understand, because I made a couple of mistakes here. So what you have to do is that just consider actual rate is this. I'm taking just to make you understand that for every 1 kilometer, as you go up 1 kilometer, the temperature will decrease by 1 degree Celsius. So here, the 10 degrees Celsius initially, you go 6 kilometers, the temperature will be 4 degrees Celsius. Is it fine? Follow me, guys. But here, 80 degrees Celsius, uh, for every 1 degree. 1 kilometer temperature, decrease by 6 kilometers. Oh man, what I'm saying, for every 1 kilometer temperature will decrease 1 degree Celsius. So how much will be there? 2 degrees Celsius. So where's the less temperature? Here or here? Here. This is the reason why equator having less temperature as compared to poles. It can be as in PT, one of the most important concepts. And did you understand why equator has a high much higher high as compared to, because of convection, vertical rising air. Fine. So this is all about this troposphere. Fine. And there is a boundary, is a layer, this is called a tropopause, that separate stratosphere and tropopause. What happens here, the temperature at first, just for some point of time it is just constant, then in troposphere temperature increase, why in stratosphere temperature increase, I'm going to tell you. Did you get that why in troposphere temperature are decrease? I'll also tell you another reason why the temperature decrease, but not here, in the next topic. Fine. So this is all about stratosphere. We have discussed stratosphere, that temperature decreases here, all the weather phenomena. Fine. uh, Confined to this particular layer only, particular this sphere only. Fine. And what else? Then we had it extends from sea level 16 kilometer along the tropic up to 6 kilometer along poles. We have discussed the strong convection wind. That's the reason why this having much higher height. Zone of mixing and turbulence. We have discussed that. Height is not uniform. You can mention that height is not uniform across globe from this only. Then what else? Let me just see. There anything that I just that we haven't discussed? Water vapor and dust particles. All the weather phenomena is restricted only in this sphere, in the troposphere. Fine. Vertical and horizontal mixing of. So this is all about troposphere. So next come to this stratosphere. Fine. Uh, let's discuss stratosphere. Now look, guys. Fine. Stratosphere. What is this stratosphere? Look, temperature increases in stratosphere. Can anyone explain why the temperature increases? I'm gonna tell you. The word strato. What is the word? Uh, the word strato. It means layer. What does it mean? Layer. So here, and its height up to 16 kilometers to 50 kilometers. Fine. Now strato means layer. So here gases are arranged in layers. Here the gases are arranged in layers. Fine. Gases are arranged in layers. That's why the name is stratosphere. Strato means layer. Fine. What else? Here is no vertical movements of air. No vertical movements of air. Fine. No vertical movements of wind. No. Fine. Uh, Strato means layer. So the gases are arranged in layers here. Height is from 16 to 15 kilometers. Not 15, 50, 50, 50 kilometers. Then no vertical movements of winds here. Fine. And there is no formation of cloud. Fine. Let me just write it here. No convection here. No formation of cloud. You know. So no convection here. Remember, guys, it can be as in 50. No convection here. Fine. And there are no such formation of no formation of no formation of cloud except there are found like except very few are found like mother of pearls, mother of pearls, and this necrosis. Necros and mother of pearls only these clouds are found because conditions are extremely dry there. Fine. So this is your stratosphere. And one more important thing that I didn't tell you why the temperature increases here. So in troposphere there is a layer is found. from 35 degree, sorry, from 35 kilometer to 50 kilometer, there is a layer found. We call it as ozone layer. Now, ozone layer, remember guys, this is important. So, ozone layer found in troposphere from 35 to uh, 50 kilometers. Fine. So, this is the reason. Then what's the property of ozone? Now, what ozone layer does that? It is naturally formed. Fine. So, ozone layer is naturally formed. This ozone layer is naturally formed. Fine. So, the sun's radiations coming to the earth, so it absorbs the UV rays. So due to absorption of UV rays, because they are having heat or they are having energy, due to absorption of these UV rays, so that's why it will be having heat in this region. So that's why the temperature increases. So why the temperature increase? Due to absorption of UV radiation by the ozone layer. That's why the temperature increases. So you can know why the temperature increases, due to, okay, should I, there is no space, uh, due to absorption of UV rays by ozone layer, the temperature decreases, sorry, increases. Fine. So this is all about this stratosphere. Let me see if there is anything that I haven't discussed. Extends from 30 to 50. Okay, it is cold, so because layers, no. Okay, UV rays in this extremely low stratosphere. Fine, this is all about it, this stratosphere. Now, this stratosphere, strato means layer, so the gases are arranged in layers. Fine. So, the conditions are extremely dry here, so there is no cloud formation. Only we find land except mother of pearls and this narcos. Then height is from 16 to 50 kilometers. Fine. Non-convection. There is no vertical movement of air. Fine. Non-convection. Convection, then there is a layer found between 35 to 50 kilometers. We call it as ozone layer. It is naturally formed. It absorbs the UV rays that are coming from the sun's radiation. Fine, and that's why the temperature increases here. Fine, and the boundary between mesosphere and stratosphere is called stratopause. Fine, so stratopause is the boundary between mesosphere and stratosphere. Tropopause is the boundary between stratosphere and troposphere. Fine, so now let's discuss this mesos yeah mesosphere. Fine, so we have discussed so far. Let me just give you a recap. Tropo and then Strato. Let's discuss Mesosphere. Fine. Now Mesosphere. Here the temperature decreases. Why the temperature decreases here? And guys, in this stratosphere, at the height of 50 kilometers, temperature reaches to 0 degrees Celsius. Fine. But as we come to this mesosphere, what happens there? Temperature decreases so rapidly at the depth of around 80 kilometers. The temperature reaches to minus 100 degree Celsius. This is the lowest temperature in the atmosphere that we found at that much depth. Fine. So let's discuss about it. Mesosphere. Uh, what it all about it. Fine. So first, let's see. First of all, why the temperature decreases here? Temperature decreases. Oh, why? You know why? Because there is no such absorption of UV rays, so that's why the temperature decreases. So there is a no there is a no absorption of UV rays or any rays. Fine. So that's why the temperature decreases here. Fine. This is one thing. So what is the it is from 50 to 80 kilometers. Fine, it is confined to 50 to 80 kilometers. We can say stratopose to 80 kilometers. Fine. This was there. Was the another property or anything about temperature decrease? You know that around 80 kilometers, at 80 kilometers, temperature reaches to minus 100 degrees Celsius. This is the lowest temperature in atmosphere. Fine. So this is there. Another one we have now this top of mesosphere we have mesopause. Fine. So this is the boundary between thermosphere and mesosphere. So this is all about mesosphere. Fine. 50 to 80 kilometers. 80 kilometer temperature reaches up to minus 100 degrees Celsius. Temperature decrease. Why temperature decrease? Because there is no such absorption of these rays that are coming from sun. Fine. Let me see there anything. Okay, one, two, three. Yeah, that's it. That's all about it. So, so what we have discussed so far. Let me just give you a brief recap. So far, what we have discussed that. Okay, we start with structure of atmosphere, and we're still discussing structure of atmosphere. In structure of atmosphere, we have divided into two. We divided the atmosphere in two layers. The inner one called as homosphere, the outer one called exosphere. So we are done with the homosphere. In homosphere, we discussed that like a uniform mixing of air. Then we have like molecular gases are in molecular form. Gases found in molecular form. Then there are three. Then troposphere, meso, and what else is there? Like uh, water concentration, water vapor dust particles is high here. Fine. So that was all about this homosphere. Fine. Then we have heterosphere. In heterosphere we have thermosphere and exosphere. Fine. So let me just see either time left or should I